Yo voy a seguir y voy a hablar de un poco de ciencia bien duro. Y no sé qué idioma elegir. Y por eso voy a empezar para relajarnos con el idioma de la música, me parece mejor. Para relajarnos nomás, no es serio. We shouldn't be too serious either. Right? You cannot be too serious all the time. You remember the picture of Einstein? That's like, we all feel relief when you see that picture. You can do very serious science and laugh at the same time. So, education for times of uncertainty. The question, how can we rethink our education system to create a generation that is better able than we are to deal with the challenges of a changing world? Very hard, right? The quote, I love that quote, I never heard it. It's more difficult to move a university than to move a graveyard. See? It's very, but, and you hear a lot of discontent about how science and how education is running everywhere. It's also, you read it in the editorial sectors of Nature and Science and all that. So we are producing too much of the same. We are producing islands of insight. So science tends to find some interesting thing and then zoom in more and more and more closely and then know everything about like a certain fish, how quickly it can swim, how many eggs will it make each year, what is the maximum temperature it can tolerate, and we know this tremendous amount. When you go to the university, they give you all those facts and you get the impression, so everything is known, what can I add? But they never tell you what they don't know. And that's much more. So that's optimistic, because it means it's lots of opportunity for the future generation. Sometimes as scientists, we cannot find the most important question. So in that sense, the story you heard from Tone Bjordan, that in the art academy, they were inviting scientists to the art school, and then they would ask questions. And it was nice for the artists, but it was even better for the scientists, because they hadn't thought of these questions. It's like if you tell what you do to just your neighbor or a kid and start asking questions, you're forced to tell it very simply, and then you get some questions, and suddenly you realize that you're either doing something irrelevant, stupid, or you didn't really ask the right question. So that's only one level of interaction between arts and sciences. That is, it's not floating in the air. That's very important, because finding the right questions is perhaps the most difficult thing in science, as it is in art. So we learned so much talking between artists and scientists these few days. One of the things I heard Riemer say is that there is a tendency to teach art students a system of working and thinking. And when you do that, they're lost for the rest of their lives, because what you're doing is you create a tunnel for them, and if they're unlucky, they stay in that tunnel for the rest of their lives, repeating more of the same boring, the same thing. And it's the same in science. There is a lot of tunneling that prevents us from addressing sometimes the really important questions that we need to address, because the world is not staying the same. It's changing radically and rapidly. What are we going to do about the climate? How are we going to think about the role of social media in information, in rethinking the world, in decision making? So many questions that cannot really be answered by the traditional sciences. So just like 3-4 weeks ago, there was an article in Science, very hard science. Science is a journal of scientists, and it had analyzed 17 million scientific articles by the computer to find out which articles were most important. And in Science, you find it out by seeing how many other scientists are citing that article. It's an objective measure of importance. And what they found is that what makes an article really very influential is that it is rooted in a certain area of science, and then it is pointing to a very different area that nobody else made a connection. And this rarely happens, and you can measure this objectively. This creates the biggest impact. And this is illustrating that's a problem that we have the islands of insight. As soon as somebody is able to make a meaningful connection to something very unexpected, very often those are the most influential ideas. So how can we avoid the islands of insight? Well, that's a lot about thinking in there. How does the brain work? We are understanding better and better how the brain works. One person, a psychologist that got a Nobel Prize, there is no Nobel Prize in psychology, but he got a Nobel Prize in economics, is Daniel Kahneman. And he got the Nobel Prize in economics because he showed that we don't decide very rationally. And maybe you knew that, but you didn't really know that, because he also showed that if there is one thing we overestimate, then it's the role of rationality in our decision making. We very much use our intuitive machine, our associative machine, as he shows. And those are two different modes of thinking. They're physiologically different in the brain, and you cannot do it at the same time. What's more, if you do one thing, you cannot do the other thing. If you are reasoning, you cannot use your intuition. It's suppressing the intuition. And the intuition is what makes the association to different things. And you can measure how well people are able to make the association. They do that with tests, remote association tests. So people who are very creative often score good on the remote association test. You say banana and they don't say yellow, but they connect it to things much more imaginative than that. Some people are very good at that, and in part it is ingrained. For instance, people that are schizophrenic make connections that are very far. They are making connections that don't make any sense. They don't filter between what makes sense and what does not make sense. And they suffer very strongly for that, because they have an avalanche of craziness and they don't know what is real and what is not real. On the other end of the spectrum are the people that are not creative at all. They rarely get any crazy association. They have a very strong filter for what makes sense and what does not make sense. And somewhere in between are the people that are the most creative, because creativity is making remote associations, but remote associations that make sense, that are useful. So it's not only dependent on the person, it's also dependent on your mood. Very nice experiments could show that if you're in a good mood, you're better able to make those remote associations. So they tested by giving the test subjects a test for association, and some should hold a pencil like this. And others should hold the pencil like this without touching the lips. You see, you get a laughing expression, and the muscles that do that make you feel better. And that in itself has a positive effect on your score on the creativity test. So, but it's not only the mood, it's also what you do. So famous thinkers in science, like Darwin, he knew that he shouldn't just sit behind his desk thinking about the problem. He went out walking every day. He had a path where he went walking. And every day he went there, and he called it the thinking path, because it was meant for him. It was a deliberate thing that he needed for thinking. And there are many other examples of like good ideas coming to you when you're not sitting behind your computer, but you're actually doing something completely else. A famous example is the benzene structure, the circular structure of a molecule. Nobody knew how that the molecule could be circular. And Kekule, who was the chemist that found it, he was thinking about, he had all those little elements in place. He knew the amount of C atoms of everything, and he couldn't think how this molecule could make sense. And he was really tired and sat in front of a fire, and he was falling asleep, and he saw these elements of carbon, and so he saw it, and he fell asleep, and in his dream he saw a snake that was biting his own tail, and he woke up. It's circular. And there are many examples of that kind of, it's an other mode of the brain that you use to be able to make the associations that you just couldn't see. So there is a lot of science about how the brain works, and there is also a lot of tacit knowledge. Like famous scientists knew that what they were doing. They had their own ways, and we never teach that to our pupils. We teach the science students techniques. We teach them how to not make any mistake, because that's what science is about. Don't make a mistake. But if you're very afraid to make a mistake, you don't take risk. You don't get a lot of novelty. So to stay in the realm of the big examples, one of the persons that we work with in Stockholm often, the center of Carl Folke, is Ken Arrow. Ken Arrow is, I think he's 85 years old, and he has a Nobel Prize in economy. And he's still very active and comes each year to work with us. He was the youngest one ever receiving a Nobel Prize in economy, and he is still very active. That in itself tells you it's a special person. And many people in economy tell me that since he got the Nobel Prize, he has had so many other ideas, developed so many lines that each of them could deserve a Nobel Prize. So what's his secret? So one of the things he told students in a seminar, he said, if you can change the topic that you study, go in a completely different direction, anytime you get the chance, do it. And we were on a boat on the Baltic with him, and I asked him more about it. And he said, you know, if you're not wrong 70% of your time, you're not doing very well. And if you're wrong, you better find out yourself. No, isn't it beautiful, right? If you're wrong, he also said, you better find out yourself. Not only because it's more pleasant, but also because then you learn from it. What that tells you about risk-taking, it's not what we teach our students. We just teach them not to make a mistake. And you have heard from Laurie Beth and Michael that actually teaching in art is very different in that sense. They teach the students to stick out the neck, to take the risk, and to then feel the control of go back. So as teachers, we think in science, we can learn a lot from art teachers. Another example is how to take feedback. Riemer has told me that, and also Laurie Beth and Michael, that they spent a lot of teaching in students how to receive critique and how to give critique. In science, we get critique all the time. We are killed and we get anxious and angry, but we don't have any training in that. So there's many things we can learn across science and the arts when it comes to teaching. The same with the tunnel. We've heard um, from artists that when in the process of creating something, and then they get, oh, it's going to be becoming beautiful, and very often, close to the end, they destroy something and falls apart, take it apart, and then it comes together, and then it's better. This is very much like the process that I do when writing a scientific article. Very often at the end, I think something is missing. It's not. It just doesn't. You feel there is a wrong connection, and you take it apart, no fear, and put it together, and it's better. I never realized I did it until I talked to the artist, and then it becomes, instead of tacit knowledge that you know it, you know what you do, but you never think how to teach it. Okay, how can we teach a generation those very like simple things often that turn out to work well. So what else did I want to? I can talk for, yeah, train critique, teach risk. Yeah. So when you hear of you hear art and science or education, you you very often um, think, well, this is maybe floating in the air, not very practical. It's a luxury, this is an intellectual spa. They are maybe drinking wine, bad for them, and waste of resources, and talking about like esoteric things. It's not like that. It's not like that. I think you've heard a lot of. We did drink wine, and it was not bad for us, but the, you heard a lot of really practical things, I think, here that we can do in the teaching. And what is also true is that there are here several people that do science and art at the same time, and that's not an exception. And actually, you can measure the effect of doing art on your science quality in a way, or at least there is a relationship. We couldn't make the Skype connection to the United States, but the people that would have spoken to us, Michelle and Robert Bernstein, are really uh, very doing very strong research into what is really the benefit of connecting arts and science. And for instance, they have done research on Nobel laureates and normal members of science academies, which are normal respected scientists, and on unrespected scientists, normal scientists, to look at the difference. And they find that very significantly, people that got a Nobel Prize do more art on the side than people that are in a National Academy of Science, and they do more art on the side than the average um, scientist. So there is this empirical relationship also. Um, so I'm not saying that so we should become very seriously about it, because as I just started, we should be able to relax and laugh about it too, right? And that doesn't, as Einstein's famous picture illustrate, that doesn't prevent you from being just the best in the world. You can be the best in the world and have fun with it. Just to finish off, because then I would like to have a bit of discussion. The SARAS Institute is going to be your neighbor here, um, and not an isolated neighbor. Well, a bit. We want to be a bit isolated, so we are out on the beach, between the beach and the mountains of the soul, the Sierra de las Animas, where Darwin also walked. We want a bit of isolation because we want time. And when I wait a bit, you feel nervous because time is pressing. One of the artists had in his workshop a clock and a fossil, and below it, tiempo es mierda, he wrote. Time is shit. And that complements very nice with when Nestor Macea was looking, he was driving around and looking for the best place for the SARAS Institute. And he found a little sign and he said, aquí es donde no existe el tiempo. And he said, this is where time doesn't exist. So, and that was the place where the SARAS Institute is coming. You cannot rush at some point. Some things need time. And that's difficult to find now. So to get back to Darwin, how would he get funding for his research? He would say, what do you want to do? He said, I want to find the origin of life. Okay, sounds good. So what will be your method? I'm going to travel around the world in a boat. Okay, very good. How long will it take? A lifetime. Okay, I'll give you the money. It's not like that anymore. And for some things you do need time. You need also time and patience to connect to people from different disciplines. So to make this connection work, that scientifically we can show, I mentioned the paper in Science, show which papers are more influential. It are the ones with the remote connections. And they're rare. Why are they rare? You rarely make the remote connections. Okay, what can we do about it? Well, you heard some about that today. We're going to do that, make that happen here in SARAS. And we need the isolation, but we also are partners of the university, of the CURE. We are here, and we wouldn't be here if SARAS wouldn't be here. So that's a little spin-off, and also that will continue in the future. We'll be around, and when it comes to this, the results of this meeting, we will publish a number of papers about that will be published in an open access scientific journal, and then will also be published in the form of a book. So that'll always take a bit of time to reflect on all the ideas, write it down. But also just, contact any of us, Isabel, Nestor, the people from SARAS here, Osvaldo, the co-director, myself, others. If you're interested in following up and being connected to this initiative. So I just invite for opening to questions now. Thank you. Preguntas, porque yo noté que había mucho más preguntas para los Osvaldo Sala que ninguna otra persona, entonces, pero pueden poner las preguntas en español también. Adelante. Sí. Yeah. Yeah. No, that's a very interesting question. So now, what is the results that you got out of it? And even that question is a question that kills you almost, because how can you predict whether you you have something profound, right? And that's in total contrast also in the sense with the way science is funded, as we were talking about Darwin. And I like to quote a Dutch writer of children's stories, that one of the characters of his book, an elephant, wakes up in the morning and he says, "Today I'm going to think of something that I've never thought of before. I'm so curious what that will be." And in a way, that is how art and science is. You cannot predict, and you cannot be pressed to have your genius result at some moment. Now, scientists produce a lot of little things. So we are trained to, like, we can write papers, and we can write incremental papers. It's 95% of science isn't very like that, not very surprising or so. It's just, and artists do the same. At some point, maybe you find you can paint in a very nice way a bird with a Coca-Cola bottle and a dark cloud or so, or so some theme, and you get that theme, and it's a great theme, and then you make like 20 other paintings that look a bit different, but are, so scientists do the same thing, but it's more difficult to predict the moment of the big insight. You cannot predict it, but you can create the conditions for it, and you cannot not expect that, okay, then I need 87 days and 7 hours, and then I'll have this genius thing that I've never thought of before, and that will change the world. It's not like that. It's unpredictable, but we know how we can create better conditions for novelty. Yeah. Yeah, so definitely. The question is, what do you think about times whose ideas whose time has come or has not come? And sometimes those are it's a phenomenon that sometimes is called sleeping beauties. Somebody gets a wonderful idea and nobody listens. Um, uh, because the time is not ripe for it in a sense. And the example in this case was the cell membrane being more important than the cell nucleus. Definitely in the origin of life, the membrane was the first thing that was needed to create reproductive cells, not the nucleus. And there are many of those examples. Dangerous for the community. The science, yes, yeah. Yeah, Galileo was yeah. So and it very often happens that an idea is filtered out. So science has a mechanism for filtering out craziness and retaining the good thing. But as often as always, you have a filter. You filter out some things that were really the good things, and this happens quite often. And there are radical examples also for Nobel prizes. One was um, the irregular crystals. The idea of the irregular that you had the irregular crystals that was later used for the computer displays and so. There was an Israeli guy. He was almost fired from his institute. It was like an insult to the community to think of irregular crystals, and he was seen very badly by the community, and he suffered a lot. Eventually, it was a great contribution to constructing computers, and he got a Nobel Prize. And there is several examples of that, and there's also um, so so it can be that an idea is very good, but it never makes it. I actually think SARAS is a very good idea whose time has come. So, I mean, now SARAS feels like you have a tremendous energy, but the ideas we want to transmit, like to connect, to be very radical in connecting, trying to create the conditions and playing for connecting, that's not very well accepted. And even there, I can mention Nobel Prize examples like graphene. I don't know if you know graphene. It's another very important, the thinnest carbon layer you can make. Very important for new technology. It was Chaim. No, it was, who was it? Yeah, I think Chaim. And it was a Russian that came to work for some time in Holland. Um, he did a lot of playing. He thought playing was very important. So first he got the IG Nobel Prize, the Nobel Prize for that is just very funny, because he wrote an article where he described how he could make a frog floating in a very strong magnetic field. And he signed the article with his co-author, who was his guinea pig. And then and he got the IG Nobel Prize. But he kept playing, and he had each Friday in the lab they did crazy playing, and he had a pencil, the one with carbon, and he put some scotch on it, and he thought, can I take off a little bit of carbon from the pencil that is just very thin, and that worked, and they gave a Nobel Prize for him because it turned out to be a very important element. So people look at you when you say you want to play, you want to go walking on the beach with an artist, or you say, that is you're wasting public money, and but that's an atmosphere whose time has not come, I think, and that we are fighting very, very strongly for, because we think that to really create this, make an incubator for strong novelty, we need to be radical. Nestor.
Es una pregunta sobre los modos de pensamiento, ¿no? Lo que se llama el pensamiento lento y el pensamiento rápido. La educación universitaria fundamentalmente en el ámbito de las ciencias se entrena en lo que es el pensamiento lento. Sin embargo, el pensamiento rápido es una impresionante maquinaria asociativa que muchas veces está detrás de las grandes innovaciones o transformaciones. Entonces mi pregunta es, ¿qué debemos hacer en la educación universitaria para promover ese modo de pensamiento?
So the fast and the slow thinking, those are the terms that Daniel Kahneman, that the Nobel laureate in economics, that was did his work on how the brain works. He used fast and slow thinking for the book. The book is a wonderful book, Thinking Fast and Slow. It's very easy reading. It's one of the few books, very easy reading, written by a Nobel laureate not in literature, so to say, that you can just buy in the airport. Thinking Fast and Slow. System 1, System 2 thinking. So we teach the reasoning, and we don't teach the association. Well, I think we can teach the Nobel winning prize theory about how your brain works. I think students, first of all, should know that our brain works that way, and we get the best out of the brain by balancing the two things. So you shouldn't be just intuitively associating all the time. You should also be very rational, because the intuition is great for getting other ideas. The weak point is that it's mostly wrong. So that's when Ken Arrow says you're not doing very well if you're not wrong most of your time, then he means that you're not using that. So I think we can teach, and we've already said that, we can teach students to take risk, to do remote associations, and I think we have a lot to learn from the arts in that sense. And perhaps we can co-teach art and science students, or perhaps we can organize also situations in which art students ask science students about the things they are studying. So helping framing the question. The other thing, I think we can all all learn from it. I only took a very little time for that. Just pulling out the harmonica. Is when we go to meetings, or organize our workshops, our classes, we rarely take a lot of time. We just sit the whole time and talk behind a table or behind a desk. We rarely take enough time for reflection, and hanging out, doing different things. It can be working, and it shouldn't be looked upon as procrastination, that in the middle of your day, or when you're supposed to sit behind your computer, you go out and you just go for a long walk alone, or with somebody else. So I think uh, we should really rethink our institutions. So Carl Volcker started the day with the quote of the Holocene, the Anthropocene, that the Economist wrote, "Welcome to the Anthropocene. We have changed the planet. Now we have to change the way we think about it." I think we have to change the way we think about thinking too, and that's where it starts.
Perdonen que de repente ya estamos un poco tarde y traigo un tema que eh, va al meollo del problema. Yo creo en la educación, como decía el compañero, y también creo en las ciencias sociales, como habla la compañera también, porque yo vine aquí pensando en las ciencias, también están las ciencias sociales, como artista y ciencias sociales. ¿Qué podemos hacer nosotros los artistas en el cambio social, en la educación diaria? Que yo soy uruguayo, pero vivo en el exterior, y llego a Montevideo y encuentro una ciudad sucia, rota, todo lleno de graffiti, igual que Buenos Aires. Y el gobierno habla de educación, estamos en crisis en la educación. ¿Y qué se puede hacer los artistas en eso, no? Pero yo por ejemplo, les indico, si quieren mirar el trabajo de el alcalde de Bogotá, Anastas Mocus, que lo escuché muchas veces y lo conozco, y con creatividad, yo creo en la creatividad, con creatividad él educó a la gente, con creatividad contrató a mimos, 200 mimos en la ciudad para recoger la caca en las calles. Con creatividad, nosotros necesitamos creatividad, los políticos, digo, y nosotros también. Entonces, la pregunta es, ¿qué nosotros como artistas podemos hacer en el cambio social también, con las ciencias sociales? ¿Sí? ¿Qué podemos influir? ¿Cómo podemos? Yo sé cómo hacerlo, pero digo, les pregunto a todos, ¿no?
So what can artists do in uh, and the social scientists for changing society for the better? I don't see any difference between social scientists and other scientists, and social scientists are strongly involved in SARAS too. That in the first place. Um, Perhaps I'm not the best person to think about or answer your question about what artists can do to help transform society, but it's a topic we have discussed a lot, and it's yet another level. Scientists can think of very smart ways how we should all behave, and then nobody listens, and it doesn't have any effect sometimes. I'm a member of the Dutch Academy of Sciences, and it's called the Academy of Arts and Sciences, but we don't have any arts. I don't know where they were lost. And now we have a discussion to bring back the arts, exactly for that reason, that we also feel that as scientists, one of the things we want to do is connect better to society. And that's very often not through the ratio, but through the emotion. That's the same as thinking fast and slow. We think we are rational. We think as scientists, we say, oh, you just do this and everything will be okay. It's not how the world works. The world works very strongly through feeling, intuition, and emotion. That's how we take most of our decisions. And artists like Tone Bjordam, but also Michael and Laurie Beth, And in Latin America, I think many artists, one of the first workshops was on sustainable water, organized by Mariana Meerhof. We saw several groups of artists in South America specifically dedicated to promoting social change through their art projects. And I think that's very powerful, much more powerful often than scientists trying to take out their message. And then they're surprised that it seems like nobody's listening. But it's just the rationality sometimes doesn't work very well. Segunda pregunta.
Marten, creo que sería muy interesante que comentes aquí al auditorio algunas experiencias de espacios que ustedes han creado en la propia Universidad de Wageningen, justamente espacios de intercambio, como todo lo que ha sido la reforma de los espacios asociados al comedor y a los encuentros, que me parece que es una instancia interesante, teniendo en cuenta que la mayor parte de los encuentros interdisciplinarios ocurren en una cantina, ¿no?
Ya, eso no es realizado, es un sueño. Yo como revolucionario, no, I decided to talk in English. Nestor is asking asking what do we do in Wageningen in terms of social engineering to create interdisciplinarity. Actually, there was an article in the journal Science some years ago where they interviewed different places working on interdisciplinarity throughout the world. They also interviewed me for the SARAS Institute. So SARAS already in an early phase appeared in the Science Journal, but then other places were quoting what they were doing, and they said actually the best thing you can do is to have a nice cantina, nice restaurant where everybody wants to go. I like that idea very much. I think that resonates with what Laurie Beth and Michael are doing around food, good food and drinks. A lot of things happen, and we are not the first one to find that out. The ancient Greeks had what they call symposium. The symposium was a place to go and drink and eat. And it turned out that was the place where most ideas and things really happened. So from that comes our word symposium. But it comes from just going to the pub, basically. So I said what we need at our university, because Wageningen University, very famous, everything, is not working the way I would like it to work, because we are very disciplinary, everybody in their own place. So I'm not going to tell, like Osvaldo, this beautiful story about Arizona State University. Wageningen University doesn't work. And I'm jealous because you have the interdisciplinary, cross-disciplinary. Wageningen says it, they say it. Everybody says they want it, but it's not happening. So I said, well, it's very simple. In the middle of the campus, and we have a very big open space in the middle of the campus, grass, you put a big tent, and you put like little wooden things there on the floor where people can sit, some hammocks, and then a wood fire. In the morning, your wood-fired oven, somebody starts baking fresh bread in the oven, and everybody goes and smells already the fresh bread. And it's this Michelin star chef that is going back to the roots and cooks beautiful food, very cheap, from local products every day, and just everybody wants to be there. There is for lunch, there are speed talks every day from all the disciplines, there are theater plays, and I was asked to open the academic year at my university with a speech, and I give all this speech about interdisciplinarity and novelty, and so this is what we need to do. So the rector and the director said, that's a great idea. Yeah, we should do that. And as it goes in Holland, they hired an architect from New York, and he made something of glass and steel, very modern, where business life could meet the university big shots. So, and they call it Impulse. And they have a small theater in it. and they say that it was my idea, but it's not my idea. My idea is much more radical. Say, we're moving a bit, and there is no restaurant, there is no food in there. Say that's the way. No, you think, and so sometimes people ask me, what are you doing here in Uruguay? And actually, I think here we can get more done than in Wageningen. I think there is more space. It's of course some things don't work, but at least in the new world things are open and experimental and moving. And especially Uruguay, I think it's a small country, and it's a living laboratory. Uh, I'm I'm envious of you taking our first position of being tolerant to marijuana in the world, but I think here things can work better than Wageningen. So I'm not going to say Wageningen is the example for Uruguay. I'm going to say I'm going to show SARAS to Wageningen, and they'll feel they're far behind. So that's the idea.